Insomnia from UnrealTech.net here, division of BlenderTech.com. It was requested how to do a space physics simulator by one of my viewers, so let's start doing that. I thought that would be something different for once. Today we're going to set up our main pawn as well as its input keys, and then we'll do some pitch, roll, and yaw controls. Later in the series we'll work on some simple gameplay we can apply to this, and then maybe some planets maybe. We'll also do some material work. So in this series you will gain a better understanding of blueprints and communicating between them, how to apply how to use the apply thrust node with physics thrusters, how that works, as well as vector and physics math. So create a new third-person project. I'm just doing that because I like the third-person guy, and let's get started. So I've gone ahead and created a blueprints, materials, and UI folder. And I've created just a dummy file on each of them and then saved so that they don't get deleted automatically. And then all the stock folders that Unreal creates, I've just colored purple. And you can color folders by right-clicking and set color. So let's start in our blueprints folder. Let's make our ship pawn. So we're going to create a new blueprint class, and it is going to be of the type pawn because a character inherits from pawn, which inherits from actor, and everything inherits from actor, which actually inherits from an object. But we don't need a character. We don't need the character movement component because we're going to be doing our own custom movement. So we don't need all that character crap on there. We just need a pawn that can be possessed and that can take input from a player controller, exactly as it says. So let's create a pawn. We'll call this BP underscore, and let's just call it Spaceship. Why not? What better name to be? So I'm going to go ahead and save that. We can delete this dummy file now. And we are going to use the stock game mode. That would be the third-person game mode for our testing. And so we'll just change our default pawn class between third-person character and BP Spaceship. So let's go ahead and change that to BP Spaceship and save. And let's delete the stock third-person character out of this level. And if there's a player start, yeah, we have one right in there. Perfect. So when we hit play, technically we have our pawn in there. We just can't control it. So let's set up some controls for our spaceship first of all. So to do that, we're going to go edit, project settings, and then we're going to go to input. And we have all our default action mapping, jump, and axis mappings, but we want to change these a little bit. So one action mapping I'd like to add is the ability to toggle through camera views. I want to have different cameras for our spaceship. So let's go toggle toggle camera view. Nice and descriptive, and let's do C for now. So let's go ahead and find the C key, and that'll be set. So an action mapping is just a key, whereas an axis mapping gives you a scale that you can work off of based on two keys, usually positive and negative. And we'll use that for pitch, roll, and yaw.
This is going to give you an action.
So to do that, let's save the stock ones for now, but let's add ones that will work similarly but separately for the ship. So I'm going to add one. And I'm going to call this just simply pitch. So I'm going to do this similarly to a flight controller where we can use the mouse up and down value. So we'll want that inverted obviously, so that when you move your mouse up you pitch down. But let's also let's add W and S to that as well. Now yes, I know you have it in move forward and move right and such, that's all in there, but I want to make these separate in case we want to make it so our player can say go into our spaceship or whatever. So W is going to be inverted as well. That's going to be pitched down. If you've ever played Kerbal Space Program, you know how that works. And S, we want to pitch backwards. So we want that to have a scale of 1, the obvious inverse. And then we want to do I guess yaw and roll. So let's do roll next. Roll is pretty standard as your secondary control. So for that, we're going to use Q and E. Again, if you've ever used Kerbal Space Program, you know those keys very well. So Q is going to be -1. And if we add E, that is going to be 1. And then we also want yaw. And yaw is basically rotating around your z-axis. So basically if you spun around in your office chair, and if you're in a plane, that's what the rudder's for, or say a ship. So that's what your yaw is. So I'm gonna put yaw, and we'll use the mouse X for that. Mouse X has a space in it, and we are gonna use a scale of 1, and that's not gonna be inverted. Your yaw is usually never inverted. And then we're gonna go A, if I can find it, there it is, and that is gonna have a value of -1, and D which is gonna have a value of 1. And then lastly we want to add we'll go engine thrust. How about? And this will have a scale of 1. And for that, I'm gonna do your pretty typical. Let's go. I think spacebar will work good, or you could use tab or enter, or we could do something else. I don't know. And then to get inverse, let's add. Let's do left shift. So left shift will give you inverse thrust. So let's set that one to -1. Now, just in case we ever need to delete our config folder if things go bad, let's go ahead and export this to our root folder, and we're just going to call it its regular input backup. So let's save that and close this, and let's open up our BP spaceship and set it up. So we have our default scene route. Let's replace that with a static mesh. We're gonna choose something for our spaceship. It's just gonna be basic for now. And take your static mesh and drop it on top of the default scene route, and that'll get rid of the default scene route. And your static mesh will now be the root component. That means any component you now add will be parented to it. But of course you can also create secondary, tertiary, and so on parenting. But our static mesh, which we're going to hit F2 to rename, and we're going to call it our ship mesh, is going to be our spaceship mesh. So I've added starter content, and we just have to go through and find something that looks kind of spaceshipy, which I don't think there's anything. I was going to use the flying template for it, but I'm sure there's something in here we can find, like I don't know, we could use that rotated, or we could use, I don't know, we got a plane, we got a quad pyramid. We could also build one out of all these too, I suppose. I never thought about that. I'm gonna look for a minute. Why not make it the stock chair? That'll be fun. So we'll make our chair a spaceship, and you want to make sure that the forward direction is pointing in the positive X. Positive X is always your forward direction in Unreal Engine 4. So you want your positive X direction to be facing. Now you can't rotate this directly since it's the root, but if you're using a custom mesh, make sure it's pointing in the positive X before you export it and when you export it. So it's very important because that'll come into play when we do the thrusters and such. So let's add our cameras now so we can actually see. So let's type in camera, let's add a camera, and this is gonna be our, let's just call it our cockpit camera. And so this will be directly the view that the pilot would have. Now make sure it is parented to the ship mesh and it's not done like that, or that it's not unparented if you were to do it like you don't even know how to do that anymore, but make sure it's parented, so like so. We want it to be attached, otherwise your camera will move, or your camera won't move, and the chair will. So we want it to be kind of where the guy's head would be, and we can test that out by compiling and saving and then playing, and we can eject, and you kind of get an idea of where your view is. So right there, so perfect. We don't want that to be our, actually I'm gonna go back a little bit. I think I'm gonna go up a little bit, and I think I'm gonna bring it down 5 degrees or 10 degrees maybe. Save, play. I want to see if we can't get this chair in the view. Let's go back a little more. compile, save, play. Maybe forward and up, and rotate it down again, another 10 degrees. There we go. I like that view. So that'll be our cockpit camera. We can scale that down if we want, hit the lock button, and we can give it like a quarter scale if we want it to kind of be out of the way. So we can go like 0.25. It won't affect the camera at all. So that'll be nice and out of the way. Now let's add a spring arm. So what a spring arm does, for those of you that don't know, is it basically allows you to whatever's attached to the other end will collide with the environment, but the spring arm will act like a spring and it won't allow the camera to clip through the environment. Our cockpit camera will clip through the environment, but we don't want our regular camera to clip through the environment. So our default length is fine. We want a little bit of lag just because I find it looks cool, so we want to enable camera rotation lag, and I find the speed of about 3 to 5. Let's start with 5. Works pretty good. Then let's add another camera, and let's call this, hit F2, let's call this just external camera or ship camera or whatever, and then take it and drag it on top of the spring arm so that you can see it automatically jumps to the end of the spring arm. Now its transform is offset, so let's just zero that out and you'll see it's right to the end of the spring arm. Now if we compile, save, and play, we're still going to see our default camera. So we don't want that to be default. We're going to toggle through that with our action mapping. So let's turn auto activate on our cockpit camera off, compile and save, and then our external camera will be default. If we hit play, we can kind of see what that looks like. We can see that's not a very good view, so maybe let's move it up. Let's rotate it down about 20 degrees. And maybe not 20, maybe 10, so we'll go back up 10. Let's move it up. Let's go 125 units. I like that. And yeah, an X should be 0, and let's go negative 10 degrees in the Y for rotation. So compile, save, play. I like that view. That should work pretty good. You know what? Actually, in fact, let's go change it from object to world movement. You'll see it rotates it the reverse of how we've rotated. Let's bring it way back. Let's go like negative 600. Compile, save, play, and let's set the spring arm to be about 600 units as well, rather, and let's subtract 300 from that. So let's take our location, X, let's just go 0. That'll give us the same value roughly. Because what I want to do is I now want to add, let's add 2, let's go for a cylinder, and let's rotate it along the Y 90 degrees, and let's go ahead and move it left 100 units. Then let's duplicate it, so right click, duplicate, or Control W, and let's move it to the right 200 units, so 100 positive. And let's select both of them, so hold down Control and then click on the other one, and let's move them back 100 units. And I think I'm going to scale them down, so make sure that it's locked. I'm going to scale them down about 0.5. And actually, I'm going to unlock it, and I'm going to scale them in the X. Let's go 0.7. Whoops, wrong axis. Ooh, that should be 0.5. Which one is it? Y. 1. Nope, it'll be in the Z since we've since the rotation is all messed up. You got to remember, since it's rotated now 90 degrees in the Y, you got to think about it differently. So our Z now becomes the X. So let's do 1 unit. So these are going to be our engines. So let's go engine, let's rename it engine L for left, and this one will be engine R for right. So that'll be our engines. Why not? So compile, save, let's hit play. So that'll be our spaceship. Why not? And we'll add some effects to these to make them look like they're thrusting. So that's our spaceship in a very, very small nutshell.
created.
And let's get some stars going. So let's go back to our map, and the default sky sphere does allow you to do some basic stars. So what we can do is search for sky in your world outliner and select the sky sphere blueprint, or you can always search for sky in the modes here, and you can just add a sky sphere. And by default, it'll use the directional light actor, which is the light source, whatever that. It's a directional light. For the lighting and determining if it's night or day. But if we clear that, it'll use the sun height in the override settings. And if we reset that to 0, you can see it's kind of like a dawn dusk setting. So if we set that to -1, we actually kind of get a night sky. So if we take the cloud opacity and turn that to, not negative, turn that to 0, turn the star brightness up to, that's kind of crazy, to like, let's say 1, then we get a very basic star setup. And I'm thinking maybe let's delete these walls. Let's delete all this setup. Let's just have a flat, whoops, don't want to delete whatever that was. Let's just have just a basic setup. So let's do everything we don't need. So that should work. And then let's just rebuild the lighting really quickly. And that will fix all of the shadows. And 411, by the way, builds lighting incredibly fast. It's absolutely amazing. So there we go. We'll just have a basic platform. And then, of course, we have this here, which is our post-process volume. We're not going to use that. And we have our light mass important volume. We're not going to need that. So we should be able to fly pretty much to the end of the sky sphere, which if you turn your camera speed up really, 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 really high and zoom out forever, it's really big. If we choose the sky sphere, yeah, you can't even see the edge. It's really big. We'll need to be going really fast to reach it, so we shouldn't have to worry about needing to do any sort of world composition or whatever yet. But this is going to be kind of like we'll call it our space dock or whatever. So yeah, there we have it. Let's call this space dock. Why not? I'm gonna get rid of this walkway folder, lighting, render effects, whatever. We'll call this space dock geometry, and then let's go ahead and save our level. So let's script our camera views now so that we can switch between them. So let's go into the event graph. Let's go ahead and right click, and we called it toggle camera view. So let's take that action event, and you'll see it gives you just a regular, as if we had used this actual C key, pressed and released. It's just that this can be used in a pawn no matter what, and it can be reset through the options at any time. So we have a regular press and release and a key structure. So we're gonna change the camera views with that. So let's do this really easy basic blueprinting. There is a nice little node called flip-flop, which goes through A the first time and B the second time. So what we want to do is we want to take our cockpit camera and we want to take our external camera. We want to activate and deactivate them independently. So by default, our external camera is activated. So what we want to do when we press this is we want to activate our cockpit camera. So drag off and type activate. You can do a check first also if you want to be a little more complex, but we're going to keep it really simple for now. So we just want to activate our cockpit camera, and then we want to deactivate our external camera, like so. Actually, let's drag these below because we'll just use them again. Let's bring these over. Let's double click to reroute, keep everything nice and neat. For those of you that don't know, I like to keep everything very, very neat. And then on the inverse, so under B, let's do a reroute. Let's do that again and just choose the opposite ones. So we will activate the external camera and deactivate the cockpit camera. So let's go ahead and try that out. So let's compile, save, let's play. So we have our spaceship. We press C, we get our cockpit camera, we press C, we get our external camera. C, 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 C. Perfect. So I like the way that's working already. That's looking good. So let's go ahead and save that. Let's select all this, comment, handles, switching between external, or let's just go ship and cockpit views. So there we have it. Compile and save. So that is the basics right there. And now, since we are going to do this physics-based, we need to take our ship mesh and we need to check off simulate physics under the physics tab. And if we compile and save and play, it's basically gonna fall to the floor. If it's not falling to the floor, then make sure movable is selected. Otherwise, everything's just gonna be stuck. And obviously, we're gonna want to disable gravity. Now, if we compile, save, and play, we will still be floating there. But if we were to hit it with something, obviously it's gonna go flying. We can very quickly do that if we wanted by creating a new blueprint actor. We'll just call this BP hitter. We could just open it up. We could add a cube, and on its event graph, we could go event tick. We could go cube, add local offset, and we want to go in what direction to hit it in the, which direction our spaceship in? It is going to be, I have no frame of reference. I believe Y though. So we want to go negative Y. So we'll just go like -3 every single frame. Actually, let's go -1. -1. Take our cube, disable gravity, enable physics, compile, save. Let's actually place our spaceship in the game and get rid of the start just for testing. Let's move it up so it's not on the floor. Take our BP hitter, make sure it's gonna hit it, and we'll see how that works. And it's totally spawning it anyway. So we have another start somewhere. Or it's spawning it in its default. So let's just turn off the default pawn class for now. And now we are not possessing. Oh, right. You need to select it. Duh. And we need to take auto possess player 0. So let's just save that and hit play. And now we should have physics working. There we go. So we have physics. It's pushing us. We have no gravity. So there is the basic physics happening in the game. So we need to get some control. Let's delete our hitter first of all. We're not going to really use that, although I guess it's good to have. So we need to work on actually getting some movement. Now, depending on how hardcore you want your space simulator to be, if you take your ship mesh and if we go under advanced here, we have, where are you? What am I looking for? Oh, sorry, not under advanced, right there. Linear and angular dampening. Now, if you want it to be extremely realistic, obviously there's no resistance in space. You would set them both to 0. But we want it to be a little bit more controllable. So let's set our linear dampening to something like 0.5 and our angular dampening to like something 0.75. That way it won't just totally fly out of control. It will slowly slow down and it will slowly stop rotating a little bit faster in the rotation once you let off the thrust. So that'll just make it a little bit easier to control and kind of tweak out at first. And what you can do too in your game is what you could do is you could take your ship mesh and you could get linear dampening and get angular dampening, and you can also set them. So we could go set linear dampening and set angular dampening. So you could actually adjust this based on, say, how close to a planet you were. So you could say have you could have a variable that constantly changes based on, say, the amount of G's or the gravity or whatever that changes those values. So that's just something for you to think about. But let's add our thrusters now. So let's go ahead and move to our viewport so we can actually see what we're doing. And what I find really helpful is to add an arrow component. And this is forward pitch arrow, is what I'm going to call it. And let's set its size to 5. Now it won't be visible in game. As you can see, it's hidden in game. It has no physics. But this will just kind of help us align if you're very new to working with the axes in Unreal Engine. So we know that's our pitch. And as our ship rotates, that is going to be how it pitches. So basically everything will pitch based off of this. So it'll pitch down and back up, and our roll rather will be like this, which you can't see, and our yaw will be like that. So if you leave this at its 0, 0, 0, 0, 0, 0, you can kind of figure out how everything is going to work. Now let's add a physics thruster. So search for thruster. Whoops. Helps if you spell it. So we're going to add a physics thruster. And this is what we're going to use to, well, thrust the ship. As you can see, used with objects that have physics to apply a force down the negative X direction, i.e. point X in the direction you want to thrust in. So if you go to translate, and if we find our thruster here, let's just move him up. You can't see, it doesn't have a mesh or anything. So it says point X in the direction you want to thrust in. So it's going to thrust in that direction. So that's how it's going to thrust. So it's going to move us forward. But if we were to rotate it 180 degrees, now our arrow's pointing backwards, so it would be pushing us backwards. So that's how you have to think about that. So I'm just going to reset these all back to 0, like so. And if you find you want something to be able to see for your thrusters, you can add an arrow. And you could set it a different color. Like, for example, we could set this to, like, say, an orange. We could set it to size 3. We could move it up here. And then you could attach your physics thruster to that, and you could call this, like, say, main thruster arrow. And then your physics thruster will be directly attached to it if you put it right. If you zero it out, 0, 0, 0, 0, 0. And then when you move your main thruster arrow, your physics thruster comes with it. So if that helps you, then by all means, go ahead and use it. Another thing you can do is you can add a sprite, or not a sprite, what am I looking for? A billboard. And by default, it is this little lion thing. And you can use any texture you want. And it will be screen space scaled, I believe. Or no, okay, it keeps the same size, but you can say is screen size scaled, and it'll stay the same size no matter what, based on your screen size here. But we will undo that, and you can do the same thing like that for all your thrusters if you need something to see. I'm going to work without them, so I'm going to set this back to 0, 0, 0, 0. But actually thinking about it, we can use these arrows to get information about our ship, such as its transform data, basically its location and rotation. So in fact, maybe let's go ahead and use them. You can get it off the ship mesh too, but using the arrow gives you a way to see it and debug while still having it hidden in game. So we're going to keep this forward pitch arrow. I'm actually going to rename it, let's just call it root direction arrow. And what we're going to do is we're going to actually add a new arrow, and we're going to call this, let's just do all of our axes. So we're going to have nose pitch, and I'm not going to call it arrow just because we know it's an arrow. And let's add our physics thruster to it. This is going to be nose pitch thruster. let's just call it thrust. So let's set this where we want it. So as you can see, I'm actually going to do it the other way around. I'm going to parent the arrow to it. So let's set this arrow first of all to be size 2, and thrust on the nose would be, let's make it blue, just like the arrow. It'd be positive and negative blue. I'm gonna make it lighter blue though. And let's go ahead and move this. Let's go about 200 units forward, and let's go 50 units up so that we can see it. So let's consider 50 units are, or you know what, rather, let's move our root arrow down 50 and then just keep this on the origin. That'll make our math way easier, because then we can just leave our thruster at 0, because we want everything to be zeroed out. Now, which direction do we want our nose pitch to thrust on? Well, we want it to push down. So we need to rotate it, and you'll see our arrow coming with it, 90 degrees. So that obviously pitches our nose down. Now, we need an inverse one on the back. So let's duplicate this and call this tail pitch thrust. And let's duplicate our arrow, and we'll call this tail pitch. And let's drag that on top of our tail pitch thrust. And let's take this and rotate it so that it's facing downwards. Your thruster, not your arrow. The arrow should be pointing downwards, but make sure you're rotating your thruster. And let's move it exactly the same behind, so we can zero it out. So 0, 0. Leave your y value alone. Actually, it shouldn't matter why the y is rotated. Oh, wait, yes it does. My bad, that should be 90. Or negative 90 rather. So if our nose pitch is at 200 centimeters, let's make our tail pitch negative 200, so we have exactly the same amount of thrust. So as you can see, that will allow our ship to pitch up and down. Now let's do the roll. So let's duplicate this again. We'll just duplicate it together if we can. So just drag the arrow on top of the physics thruster. So this is going to be, let's go left. We'll go wing thrust. Can't spell thrust. I'm just going to copy paste thrust. Or no, this will be left wing arrow, and this will be left wing roll thrust. And so let's set this back to 0, 0, 0 and 0, 0, 0 on the rotation. So let's take our thruster and let's move it 200 units on the left wing, so negative 200. And so we are going to want this to pitch downwards, I believe. So if we go negative 90, just like that, that'll be the way it is gonna thrust. And since we are working with roll, which I would associate more with the orange there, let's set this to orange. Something like that. Looks good to me. Actually, let's size all these arrows 1, because they look kind of ridiculous to me. We'll make the main thrust ones bigger, and then let's make one for the right wing, pretending we have wings, but we're gonna need we would need them either way. So drag the arrow on, so this will be a right wing, and this will be right wing thrust. And again, let's do the same. We want the inverse rotation, so we want positive 90. Make sure everything else is 0, otherwise your stuff is going to go off slightly. And we want it 200 units. We want the exact inverse. So now we can roll and pitch. So we have 2 axes. Now we just need to be able to yaw. So that's basically pushing the front of the ship. So if we're looking down on it, we need to be able to rotate it like this. you know, spinning in a circle. So to do that, I'm just going to duplicate this one since it's right in the perfect location. Or sorry, I'm going to duplicate the front thruster, the nose pitch thrust, because it's in the perfect location. And let's drag the arrow on top of it. This is going to be nose yaw. I'm going to call this nose yaw thrust. And let's make this one the last arrow color, which is the yellow. And technically, actually, it would be orange, or would it be? Technically, it would be blue for. I kind of got those confused, but whatever. We'll just, it doesn't really matter what the color is technically. So let's just make it kind of yellow green. And we, or I guess rather, whoops, I shouldn't have set that one. Let's undo that. We want the nose yaw to be that yellowish green. And then what we want to do is we want it at that location, but we want to rotate it so that it's pushing from this direction. So -90. So we go 0, -90 in the Z, and -90 in the X, and 200 units. So as you can see, it's going to push from the left. Just like that. And now we need one at the back that pushes from the right. So let's duplicate this. Bring the arrow down. So this is going to be tail yaw. And the thruster is going to be tail yaw thrust. And then we're just going to, again, invert it. We're going to go -200. Make sure you have the thruster. And then we just need to do it the other way. So we just want to rotate it 180 degrees. So press E or hit that right there. And we just want to rotate it so it's 180 degrees around. So it's pushing that way. So make sure these are 0, or make sure these are perfect values. Otherwise it will throw space physics off. 0 and 90. -200, 0, 0. Perfect. So that is all of our thrusters set up, except for our main thrusters. But now we can control our ship totally. So let's wait on the actual thrust, and let's just work on getting these worked out properly first so that we can control our ship. So let's start with roll. So if we remember, if we go back to our project settings and go back to input, under axis mappings, we had pitch, roll, yaw, and engine thrust. So let's start with roll, I think is what I said. So let's go ahead and bring that event in. So let's search for roll, and we have both our axis value. So we get the value of it, which we'll use later, but we want the axis event. So this is input axis roll. And so you'll see if we do a debug, if we just go print string, and if we plug the axis value into it, remember we put it to, if we go back to this very quickly again, input roll, roll we put to Q and E. So you'll notice if we compile, save, and play, it's 0. If I hold down Q, we get -1, and if I hold down E, I get 1. So we know that's working. But we need to actually use it to apply thrust in some way. So what we want to do, let's create a variable called roll strength. If I spelled it right, yeah. And this will be a float. And let's hit F7 to compile, and let's give it a default strength of like 10,000. And so what we want to do is on here we want to go. We want to take the axis value and we want to multiply float by roll strength. And then we want to bring in, this is for roll, so we want to go left wing roll thrust, bring it in, hold down control to do a getter, and left wing, and where's right wing roll? Did I not add a right wing? Oh, I called it right wing thrust. That should be a roll though. Yeah, right wing roll thrust. My bad. Let's rename that. right wing roll thrust. So what we want to do is drag off of it, and you can search for thrust, and you can see we can get and set thrust strength on all of these. So let's go ahead and do that. Let's set thrust strength of each of them, and let's just see how it works. So we'll line this up, and then we'll do this one. Set thrust strength. And we'll just plug in that value to both of them. So let's just see what happens when we press our keys now. Save everything, play. So we have our ship, so when we hit Q, not a lot's happening. When we press E, not a lot is happening. Why is that? Well, are they activated? No, they do not auto-activate. They need to be activated manually because thrusters are kind of binary. They have an on or off state. So we need to make this a little more advanced. So what we can do is we can activate that one, and we can activate this one. That's not going to be enough though, because obviously we need to deactivate them, otherwise we're just going to continually roll. But let's see what happens. When I press Q, we roll to the left a little bit. When I press E, we roll to the right a little bit. If I hold down E, we basically spin. If I hold down Q, we slow down, and then we spin the other way, and we're spinning in the proper direction. So that works great. But we want to turn them off when they're not in use. How do we do that? Well, the easiest way to do that is to make this slightly more complex. Let's take our axis value, and we want to check if it's not equal, float to 0. So basically, if we have any input, because you noticed when we debugged, when we're not holding it down, it was 0. So if it's not equal to 0, then that means we're pressing a button. So in that case, then we want to go into a sequence, and we want to actually set our thrust strength first, and then we want to activate. So we can kind of just reorganize our nodes here. We can straighten these out with my hotkey if we want. Just like so. Perfect. And then we still need to plug the axis value into our roll strength variable, however. So let's make sure that, let's see, how can we do this nice and clean? Something like that, I guess. Actually, we don't need a sequence in this case. I was going to do them separately, but we'll just do them together. And then if false, we just want to deactivate them. So what we can do is we can copy these again and deactivate. Whoops, deactivate. Like so. So if false, make sure they're deactivated. So deactivate. Like so. So we compile, save, play, so we know it's gonna work. But how do we know it's actually deactivated or active or not? Well, let's go ahead and create ourselves a quick little UI. So under the UI folder, I created a widget dummy file. Let's rename that widget underscore main HUD. So open it up. Let's create let's just throw 3 images. I'm just going to do this very roughly. 3 images. and let's put text beside each one. Actually, let's move these over rather. Actually, no, we can put them exactly how they are. Just give a little bit of room. And let's go pitch, roll, yaw. Whoops, not yaw, yaw. And so, come on. I hate the way that works. Yeah, okay. It's still giving me problems. Oh, I have caps on, that's what. There we go, okay. So let's go ahead and select our image for roll and take the color and opacity and let's set it to red for off by default. Let's do that for both of these. Color and opacity like so, and then let's do something a little fancy. Go to the bind button and hit create binding, and let's call this get color underscore roll. So what we're going to do here is we're going to check if the thrusters are on. So what we're going to do is we are going to let's go to our event graph and delete everything. Let's go event construct. So when this widget is created, let's get player pawn, and then drag off of that and cast to BP Spaceship. We want to imp here, so make sure it looks like that. And then let's take the return value and let's promote to variable, and let's call this our spaceship. And if the cast fails, let's do a print string, and let's just go error ship not found. So now we can use our spaceship to get data off it. So let's go back into our get color roll function. Let's drag in our spaceship as a getter, hold down control, and let's get roll. So we want to get child component, I guess. No, get left wing roll thrust, get right wing roll thrust. And then what you can do is you can drag off of them and you can search active, and you can see is active. So let's do an is active for both of them. So go into create a branch, hold down B and click, and plug it in like so. And what we want to do is an and. So if both of these are active, true, then let's return green, so full green. If false, then just type in add return node. Then we're going to return red, pure red, like so. So let's see how that works. Compile, save. We need some way to show that, however. So let's go to our blueprints. Let's right click. Let's create a new blueprint class. Go to all classes, type in HUD, select, and let's call this BP underscore HUD. Open it up, go to the event graph, and let's go event, or just hold down P and click. It'll give you an event begin play. Let's create widget. And let's create widget main HUD, owning player, get player controller. And then let's take the return value and let's go add to viewport. So that'll add it to the screen. So let's compile and save that. And then let's go to our world settings, and under our HUD class, let's search and select BP HUD, save everything. Let's hit play now. So now you can see we have our pitch, roll, and yaw. And when we hold down the button, it turns green, and when we let go, it turns red. And when I hold down E, it turns green. And then it turns red. So now we have a visual indication for roll. So let's go ahead and set up the rest of them. So let's go to our spaceship and let's just do the same thing for the rest of them. So let's go yaw strength. Actually, let's just duplicate this and just call it yaw strength. Duplicate pitch strength. Now, the yaw is fine, but the pitch, we probably want a little bit, it'll be fine. Let's set them all the same. So let's just copy this to make our work easier, and let's bring it down a little bit to make it clean. Let's comment this, handles rolling. Let's copy this entire thing, and let's paste it. And then just to make our lives easier, let's zoom in. Let's delete input axis roll, and let's go input axis pitch, and let's just plug it back in and plug in axis value. Remember to plug it in down here too. And now all we need to do is just take these and just replace them with pitch. So we have tail and nose pitch. So we want nose, whoops, wrong one. We want nose. So just drag it on top until it says change node to read, and then it changes it. So we have nose and we have tail. So tail, change node to read, change node to read. So let's compile and save, excuse me. And let's go ahead and test that out. So now, whoa, they are auto activating. Or right, I forgot I applied it to the mouse. So the mouse can bring it up or down. That's kind of not so fun. So I'm actually gonna get rid of that completely. So I'm gonna go to input. I'm gonna get rid of the mouse Y. I could just go scale 0, but that won't work out. So I'm just gonna get rid of the mouse completely for now. So let's compile, save, play. So now it's completely normal. We can do our rolling if we want, and if I just get us level again, we can also pitch. So W is pitching me up, so that's actually backwards, and S is pitching me down. Although I guess depending how you look at it, depends how you prefer to use that. I prefer to have it the flight way, so I'm actually going to go and invert that. So I'm going to go to input, I'm going to go to pitch, and I'm going to switch those. I'm going to go 1 and -1. I prefer it the flight way. So now when I hold down W, it pitches me down. When I hold down S, it pitches me up. So we have that set up. Let's go to our UI and let's duplicate this and let's call it get color pitch. And all we have to do here is just check get pitch. So get tail pitch, get nose pitch, and just make sure they're active, and they're going to return the same thing. So compile. Oops, I totally did that on roll. Well, let's copy it, undo that. I always do that. Open up pitch, delete those, paste, connect them up, compile, go to your designer, select pitch, and then bind it to get color pitch. Compile, save, play. Now when we pitch, it's not working at all. Why is that? Our roll works. Get color pitch, let's go check that again. So tail pitch and nose pitch, are they both active? If true, return green. So we're not activating both of them. So I messed something up. So nose pitch, tail pitch. If it's not equal to 0, we set the thrust strength and we activate them. So they should both be active. That's very unusual. Nose pitch thrust, tail pitch thrust, nose pitch thrust. Oh, I've got the totally wrong things. I need to get nose. I was using the arrows. I needed the thrusters. Tail pitch. So I just, whoops, not set. Get tail pitch thrust. I just had the wrong component is all. Those are always inactive because you don't see them in game. So now, as you can see, that works just fine. Perfect, so we're getting closer. While we're here, we might as well just do the yaw. So let's duplicate, get color, yaw. Open that up and let's just get yaw. Make sure we get the right ones this time. Get yaw. Compile, and then go to your designer, choose the yaw image and bind it to the yaw function. Compile, save, and let's go back to our spaceship and let's first of all handles pitching. Now let's do yawing. So copy that, paste, make it nice and neat. So handles yawing. So this will be our last one. So let's just replace these with yaw. So nose yaw goes into nose pitch. And tail yaw goes into tail pitch. So compile and save. Oh, what did I screw up? Found more than one function. Input axis. Oops, I forgot to set that to yaw. So we need input axis yaw. So yaw I set to A and D. So if we hit play, when I press A, we spin around. And as you can see, the physics kind of throws us off balance. That's due to our angular and linear dampening values. And D, we go the other way. So that's all working great, but we need some way to move forward now. We could probably get rid of the floor if we wanted to. That would look a little better, I think. And if we wanted, we could probably even duplicate the sky sphere. And we could maybe rotate it 180 degrees. No, you just see the horizon. You need to create a custom sky sphere to see stars all the way around. And obviously, if you delete the sky sphere completely, it's just going to be that. So yeah, you need to create a custom one, but that's fine. I think that looks a lot better though. But there is a sun, so we need to get rid of that sun. Well, I guess there's nothing wrong with having a sun, just like having a sun in space. Just need the darkness. But that's for another lesson. Let's go ahead and create the main thrusters now. So what we're gonna need to do for that is, let's go input thrust, engine thrust. And what we want to do is we want to multiply this by a float. And let's promote a variable. Let's call this engine power. And let's hit F7 to compile. And let's set that to 20,002. 20, 1, 2, 3. And what we want to do to be able to thrust in the same direction, because otherwise, remember, if we're rotated and we thrust, we're just going to push forward in object space, but we want to push forward in, or we would push forward in world space. We want to push forward no matter in the direction that the arrow is pointing in all directions. So to do that, what we can do is we can take our root direction arrow, we can get world rotation, and then we can get the forward vector from that. And as you can see, it will get the forward vector by the given rotation. So that will always give us our positive X, if you will, our forward vector. So the forward direction for our ship to move in. So now what we can do is we can take that forward vector, we can multiply it by a float. Whoops. Multiply by a float. And if we plug that in, that gives us a vector to move along and a strength to move along it. But now how do we move our actual ship is the problem next. Well, the way to do it with physics is to take the vector and add impulse. And we want to add impulse to the ship mesh since it's our root. The engines are just there for looks, but we could, whoops, not add angular, my bad. Add impulse. And that is our impulse. Bone name is none. That means it just applies it to the entire thing. And so that will add whatever our engine power is based on the axis value, which we did shift and space. So if we simulate shift space, not going to work right now. But if we compile, save, we can also we can debug it with a print string first of all, just to make sure it's working. Plug that in, compile, save, play. So space gives us 1, left shift gives us -1. So let's see what that does. So add impulse, compile, save, play. So shift, it's doing something. Space, also doing something. Looks like that may be fairly strong though. We need a frame of reference. I kind of got rid of our frame of reference. So what I'm gonna do is I'm gonna search for a cube. I'm gonna add a cube into the scene. I'm gonna add it at 0, 0, 0. So right at the origin. And I'm gonna add one every maybe 500 meters. 250? I don't know. So let's go cube, let's just call it 0. Let's duplicate. Where are you, duplicate? Okay, let's just copy and paste then. That's gonna be 250. And let's move that 250 meters along the X, so forward. So 250, 1, 2, 3. So that's 250 kilometers. 250 hundred rather. So that's 250 I live in Canada, I should totally know this. It should be 2500 is that's 25 meters. So yeah, 250 would be, or 25,000 would be 250 meters. 25,000 divided by 100, 250 meters. That's actually really far, but that's fine. I'm going to duplicate it one more time. Copy paste. I'm going to call this 500 and we're going to set that to 50,000. So 50, 1, 2, 3 divided by 100 gives us 500 meters. So now we can play and we can see how that is working. So if we hit space, as you can see, we go forward, that's 500. So that's actually moving pretty darn fast. So maybe let's set our engine power down to 10,000. So 10, 1, 2, 3. Compile, save, play, space, there we go. Now remember, you don't stop when you let go. We do, but very slowly. And if we hit space or shift, we go backwards. And now we can move in all directions. But let's go to our main HUD and let's we're not gonna put our thrust here. We're gonna do that with materials, but we need some values. So let's take our pitch and let's create binding, and this is gonna be get pitch value. So to do that, we're gonna take the return node, drag off of the text, and we want to format text. So we want to type in this is pitch, so we want to go pitch colon space, and then in curly brackets, you'll notice if I type in something like ABC, it'll bring in a pin and it will replace the curly brackets and ABC with whatever I put in there, whether it be a value or whether it be something I type in directly. So we want pitch, pitch, and then we'll just say degrees. So let's go D. Why not? We'll just leave it as a value. And so what we want to do there is we want to take our spaceship, we want to Now you can't just get pitch. That doesn't, there's no such thing as pitch. But what we can do is we can get world rotation of the ship mesh, and this will give you a rotator, and if you split it, it gives you your X, Y, and Z, or your roll, pitch, and yaw. So if we plug in pitch, it'll replace pitch with whatever our Y value is in world space. Now we want to go into advanced, and we want to do some editing here. The minimum digits we want is 1, obviously. The maximum we want is probably like 5. The minimum fractional digits, so this is after the decimal, 0, and the maximum fractional, depending how accurate you want, can be anywhere from 1 or 0, I guess technically, to I don't know, about 15, 16 digits for a float, I believe. But I'm gonna do it to 2 digits, so tenths, or hundredths rather. So if we hit play now, you can see our pitch is 0, but if I pitch us down, we now get a value. And our camera's doing weird things too. But notice that, well, what is going on? Notice that it is giving us values. I'm gonna first of all size this to content, so that when we play, it should always, yeah. Notice that it is, why is our ship going all wonky? It's like it's hitting something. Maybe it is hitting something. It's not giving us full 360 degrees. It's only going, if we go very slowly, it's only going to 90, and then it's going back down, and then 0, and then to negative 90, and then back up. And let's go ahead and do the same thing for all of these. Roll, size to content, yaw, size to content. Let's create them for roll and yaw as well. So let's get pitch value, duplicate, get yaw value, and then let's duplicate, get roll value, and let's do one more, duplicate, get speed. So pitch we got, yaw, let's just plug in yaw. Roll, let's just plug in roll. Get speed, what we can do is we can take our ship mesh and we can get velocity, get component velocity, and that'll be in centimeters per second. And so that returns us a vector. So we need to unrotate, get forward vector, and actually the easiest way to do this is get component velocity and then split the struck pin so that we have a float to work with. And we want the X, Y, and Z value, and we want to add them. So plus, and then add a pin. We want to add them all together, because if we're moving both forward and left, we have a combined velocity. If you wanted though, however, you could get forward vector, and then you could split that one, and you could just get the X if you just wanted your straightforward velocity. And then we can take this and divide, not divide by a vector, we can divide by a float. If we divide by 100, because that's in centimeters, this will give us meters a second. So speed by speed, so plug return value into speed, and then space m divided by s, meters a second. So I'm gonna go meters a second, like that. So let's compile and save that. Roll, let's change that to read roll. The pitch part doesn't matter, we can leave that. And yaw, let's change that to yaw. Oh, and very important, we will have negative values. We want positive because you don't really have a negative speed. You just get closer to 0. So make sure you do absolute after that. That'll give you an always positive value. So compile, let's go to our designer. Let's plug in our, we got our pitch. Let's go roll. Let's go roll, yaw. Let's put yaw. And then let's add a text box and size the content. Let's make this slightly bigger. Let's make it 32. And let's bind get speed. And this will just be speed. Kind of just a placeholder. Let's compile and save and play. So now we can, you can see we have our roll is still not work. Oh, because I'm not rolling. So you can see it's giving us our degrees. It still needs some math to work perfectly, but it is technically giving it to them, or to us. We need a little bit more math to get them to give us 0 to 360 degrees. You can see we get 180 on some of them and to 90 on pitch. But we'll work on that later. And we also have speed. And if we go backwards, it's still positive. And no matter which way I go, it's still going to go down slowly because of our linear dampening. But as you can see, it goes down slower and slower and slower. But no matter which direction I'm going, we still have the same speed. And you'll see it'll slowly, slowly, slowly go down to 0. Until it hits, we're basically going 0 now. We're still moving, but basically 0. If I find that cube. Oh, it's been a long time since I played with ship dynamics. You can see, yeah, it's going to take us a long time to get there. We've essentially stopped. But there you have it, a very basic setup. Let's set up our engines lastly to give us a thrust look. So let's go to our spaceship. So let's set up these engines so that we can see that they're actually on based on our speed, so that we get a glow based on their speed. So what we're gonna do is we're gonna we're gonna go to materials and our material dummy file. Let's go m_engine thrust. Let's open it up. And we want base color and emissive color. I'm thinking. Yeah, let's do that. So go ahead and type in a 3 vector. So hold down 3 and click, and that'll give you just a regular color. And what we want to do is plug this into base color and plug this into emissive color. And then we want it to obviously be something like a light blue when at full thrust. So it would look something like that. Kind of like an ion engine. But how can we modulate this by speed? Well, what we can do is we can take this and we can turn it into a material instance instead. So what we can do is we can search for vector parameter, and then what we will do is the default value we will set to so when our engines are off, we'll just leave them as, yeah, kind of their medium gray, full alpha. Let's call this parameter name thrust, lowercase, and then just plug the white back into base color and emissive. And let's save. Then let's close it. Let's right click and create material instance and call this mi_engine thrust. Open it up and check off thrust as a vector parameter value and save. Now let's go into our spaceship and let's set our engines to that material instance. So mi_engine thrust. Oops, I could have done them both at once. Oh well. Mi engine thrust. So what we can do is we can go and we can comment this to, oh, I hate when it doesn't comment. Handles moving forward by engine power. So let's go to the very top and let's create an event tick event. So every single tick, well, first of all, let's go event begin play. Let's create a dynamic material instance for engine left, and that source material is going to be mi underscore engine thrust. And let's do the same for engine R. Create a dynamic material instance. There's ways that you don't have to do this twice. Ah, shoot, I did the wrong one. Target should be engine R. And that should also be mi engine thrust. And let's promote this to a variable. This will be engine L. We'll go material dynamic underscore engine L. Let's set that. And then we'll promote this one to a variable. Right click, promote to variable. This will be material dynamic engine R. Let's compile. So that'll create dynamic materials. And so what we can do is on event tick, we can get this value down here, which is our access value by engine power. Actually, we should be able to get impulse, maybe. Do they have nowadays? No. That's too bad. But what we can do is we can take that same value we got for speed, so get component velocity. So let's just copy that. And we might have to do some extra math, but we can copy that in. We can replace this just with ship mesh, like so. So that's how we get our speed in meters per second. And what we can do is we can take both of these dynamic materials and we can set vector parameter is what I'm looking for. Oops, I guess I have to turn that off. Oh, you know what? That shouldn't be a vector. I screwed that up. That should be a, let's go back to our material. Scalar parameter, I believe. No. Parameter. Come on. Parameter. We want a, yeah, a vector parameter. RGBA. What am I doing wrong? Set vector parameter value. One of these is the right one. There we go. Set vector parameter value, like so. And so that takes in a linear color. And so what we can drive that linear color based on that float value. So let's do it for the other one too. So we're doing this every single frame, so it's constantly updating. And remember, it has its default of gray. So what we want to do is we want to use these to drive a linear color. So we want to create linear, or sorry, select, no, what is it? Linear color. We want to lerp linear color, yes. So we want to go between A, which is going to be our gray, and B, which is going to be our full thrust color, whatever you want to do. Let's do green, why not? And our alpha will be driven off of that. So we can plug that into both of these, and make sure you put in your parameter name. Remember, that's thrust. And I haven't done this in a long time. And if all goes to plan, now it might give us some funky colors at first, but it should change colors. There we go. And as we slow down, as you can see, it gets really bright as you speed up. So we might have to divide it a little bit more. Our alpha basically is between 0 and 1. So we're driving it. We need to divide it by another 100. So that would be obviously 100 times 100, which would be 10,000. I think that'll give us what we want. Let's try it out. 10, 1, 2, 3. And we always want a positive value. You wouldn't want a negative. Let's try that. Compile, save, play. So I hit shift. That's a little too little. I mean, yes, full speed is going to be about 100. Because it's 10,000 centimeters a second. But I want a little bit more than that. So let's go like 5,000. This is, you can tweak it for yourself, but about 5,000. Compile, save, play. So yeah, there, that looks a little bit better. We do have the unfortunate value that it goes straight back to gray in between. So you could have it between, like, say, really light gray, as if they're almost on, or like a gray green, sorry, and then to bright green. And you could even turn the alpha down. Actually, that'd be kind of cool. Compile, save, play. Maybe even lower. 5%, so it'd be almost invisible. That's kind of cool. Yeah, so you can drive those in any way. And you can even take this and you can do select color, and you can say if this is greater than, say, I don't know what values this is giving us. If this is greater than 0.005, let's say, I'm just guessing here, instead of light green, or instead of lime green, give us yellow instead. I don't know, whatever you want, right? Compile, save, play. So I don't know what values we're getting, so what I'm gonna do is I'm gonna also print that just to see. So I'm gonna do a print string. I'm gonna get this value. I'm gonna find out exactly what value we're getting, so that I can show you how to do that cool thing too. Compile, save, play. So we're getting like 0. Yeah, we're getting over 1. So full speed would be like 2, it appears. So it's always gonna pick A. So pick A if it is greater than 1.7. So once we get fast enough, you can see it goes between green and yellow. And yeah, I don't think they'd be a little bit more advanced to not have it when you go in between forward and backwards, to not go back to your base color. I don't think getting rid of the absolute would do it. Try that. Whoa, what happened there? Never seen that before. That's kind of annoying. There we go. yeah, it's just giving us some funky values now. So you just have to play with it. But because the negative values gives it some weird stuff. But yeah, you can do all sorts of stuff there by lerping between different colors and so on and so forth. And you can even play with the material. You can output, say, you can add, you know, the red and green together, and then add just the blue, and you could make one of these a scalar parameter. So you could scalar parameter. So you could add a scalar parameter, and you could make that a certain value that so depending on how you play, you know, your knowledge of materials, you can get some interesting looks. But yeah, that is a basic space flight simulator. What else am I thinking of? The other thing I want to do is for the camera switch. So we have that, and you have our first person. So I'm thinking if we go to our widget main HUD, what I would probably do is add another canvas panel to here. And in here, I also want to size to content, anchored all four corners. You could do something like you could create a cool you could create like a cool cockpit view. I'm just gonna do something really stupid quickly, but oops. Why am I not seeing that one? It's very odd. Alpha is there. Oops. There we go. I had that wrong. And we're just gonna make these black. And we are going to set them to visibility is going to be hidden, and then we're going to create binding, get cockpit image visibility, and we're going to go select. And so option 1 is going to be visible, option 2 is going to be hidden, the index is going to be we want to get our spaceship, we want to get cockpit camera, and is active, and that'll be our boolean. So if false, it'll be hidden. If true, it'll be visible. So compile, save, play. So regularly you get this, but if we go and switch cameras, then we get our little cockpit view. So you could do whatever you want, right? And obviously you would want all of these to be at a higher Z order so that they're always on top. But you could set those up to be in a different position and stuff too in the cockpit. So you could make some really cool stuff, and there's some cool stuff people have done. But that is a spaceship simulator in a nutshell. You can go absolutely mad doing whatever you would like now. You can attach components and make the next Kerbal Space program. So yeah, hopefully that helps you guys out, and any questions, let me know, and hopefully that helps the person out that asked. So thanks again for watching. If you learned something, please like the video, subscribe to the channel as well. We take donations at paypal.me/BlenderTech. We also do private tutoring if you check at unrealtech.net or blendertech.com. If you dislike this video, please tell us why. So we'll see you next time. Remember, create your way.